Morning everyone, my name is Karthik. I'm pursuing my BTech in VVIT College. I'm from CSE department. Let us discuss about ER diagrams, how we represent them, what they are actually. So ER is a short form for entity relationships. It is a high-level data model language. This model is used to define the data elements such as uh, attributes, entities, and their relationships among different entities, etc. It also develops a simple view, simple design view of the data. Yeah, in the ER modeling, the database structure is portrayed as a diagrams called ER diagrams. There are many components in the ER diagrams. Let us see what are they. So let us take an example. You can design a school database like this. Here, a student is an entity, and it consists of attributes like name, address, ID, and age, etc. These are the attributes of him. So this is how we represent the uh, entity relationship. So let us discuss about components of ER diagram. ER model is mostly classified into three: entity, attribute, and relation. And each component has types. Here, let us discuss about each of them separately. Entity. An entity, it is an object or a class or a object which is either a class, a person, or a place. In the ER diagrams, an entity can be represented in the rectangles as shown here. So consider this example. This is a simple entity showing a relationship between two entities. Here, employee is an entity, and department is also an entity, and these are connected with the relation called works for. We will discuss about this relations in the next slides. Let us discuss about weak entity. A weak entity means uh, it doesn't have any specific attribute on its own. As we can see here, a loan is an entity and an installment is an entity. But an installment only depends upon the loan they took. So installment doesn't have any meaning unless there is a loan. So installment is represented in double rectangles, which represents it as weak entity. Let us see about attributes. Attributes are like they are like variables. It is used to describe about the property of an entity. It is represented in the eclipse shape. For example, here in the student is an entity here, and this student entity consists of an ID, phone number, name, and age. So ID is an attribute, phone number is an attribute, name is an attribute, and age is an attribute. So these are all attributes of a student object. So we are representing in this way. Let us see about key attribute. The key attribute for a object is the main characteristics of an entity, which means it is unique and it represents that entity. The key attributes is also represented. Key attribute is represented as underlined here, as we can see here. So ID is the key attribute here, which means it is unique and it defines the uh, you know each characteristic of an entity. Let us see about composite attribute. Composite attribute means, as we can see before here the name. So we may have first name, last name, and middle name. So composite attribute is an attribute which have an attribute consisting of many other attributes is called as composite attribute. Here name consists of many attributes. Here first name, middle name, last name. These are connected with an ellipse. As we can see here, it is an attribute and it consists of other attributes like first name, middle name, last name. Multi-valued attribute. for some for of let us see if in the real life we may have more than one phone number. So how to represent that? It is by using the multi-value attribute, a attribute which can have more than one value. For example, a phone number, we may have two or three phone numbers. So this can be represented as using double vowels. Let us see about derived attribute. So derived attribute means an attribute is derived from another attribute is called a derived attribute. So let us see here. There is a birth date. What we can find from the birth date is we can find the age from that birth date. So it is represented as, see here, it is represented in dotted lines. So derived attribute is represented as dotted lines. Relationship. So relationship means, as I discussed earlier, it is used to represent the relation between two entities. See here, a teacher has a relation with student. Since teacher teaches the student, so teachers will be the relationship between the teacher and the student. This is how we represent the relation. Relation have actually one to many, many to many relationships. One relationship means and one instance of an entity is associated with the relationship, then it is known as the one relationship. For example, a female and a male can be married, only married to one female or male. So as we can see here, a female has a one relationship with male, and male has a one relationship with female. So it can be represented either this way or m is to n. I mean 1:1. So here married to is the relation. One to many relationships, when one instance of the entity on the left or right has more than one instance of an entity on the right associates with the relationship, then it is known as one to many relationships. As we can see in this example, a scientist can have many inventions, but if a scientist has a list of inventions, then all the inventions are listed on the same scientist, right? So this is what described here. One scientist can invent many inventions. Those inventions are invented by only one scientist. So as we can see here one to many relationship with respect to scientist, and the invention, from the invention point of view, many inventions are invented by the scientist. See, as we said before, when more instance of an entity on the left has only one instance on the entity on the right side, it is called as many to one relationship. For example, see here, a student can enroll into many courses as he want, but once he's joined the course, he cannot join again in another courses. So many students can join into one courses. So but this course can have many students, right? Student can only enroll for one course, which is many to one, and the course can have many students. One course may have many students. So that is what here it is described. Many to many relationship. So there is a point there where one instance on the left side, I mean many instances on the left side has relationship with many instances on the right side, then we call it as a many to many relationship. For example, employee, so in a company, one employee can be assigned to many projects, and the many projects can have, one project can have many number of employees. There is no restriction here. As we can see here, many employee can be assigned to many projects, and the projects may have many employees. So this describes the many to many relationships. So this is all about entity, relationships and the attributes in the ER diagram. Thank you.